Okay, so you should be watching this video after having completed the perimeters and areas of similar figures activity. We're going to do that as a whole class. So after we're done that, you should be watching this video. I'm going to scroll down to the end of the video, or the end of the activity, sorry, and look at the beginning of the notes. All right, perimeters and areas of similar figures. So hopefully you've already discovered that the perimeter, the ratio of the perimeter, so we're talking about similarity ratios, and ratios are fractions, okay? So a similarity ratio, remember, is a comparison of two numbers, and they are usually written in fractions, okay? So I want you to keep that in mind, usually written in fractions. So the perimeter, the similar figures, the similarity ratio of the perimeter is A to B. So the perimeter of one figure is to the perimeter of the other figure, okay? A to B. So that means perimeter of A, wow, my marker is really being annoying. Okay. So we have the perimeter of A is to the perimeter of B. All right, area. Something changes in the area a little bit in that we have A squared over B squared. So the area A squared over the area B squared. All right, so these are the ratios, okay? So let's put that into use a little bit. Finding the ratios of similar figures. So let's look at this first example. Two trapezoids have corresponding side lengths of 6 and 9, okay? 6 and 9. So I'm going to put the 6 here and 9 here. 9 because it's longer, so I'm going to put it on the bigger figure, and 6 is smaller, so it goes on the smaller figure. Find the ratio of the perimeters. So we already know the ratio of the perimeters, so perimeter, so it's going to be A is to B. So we're going to go 6 is to 9. So the side length of one is directly proportional to the side length of the other. We know that because they are similar. And remember, in similar figures, the sides are proportional. We talked about that when we did our whole chapter on similarity. We said we had to constantly check to make sure that all the sides proportions all reduced to the same number to make sure that they were in fact similar to each other. So we're going to reduce this because they're both divisible by 3, and we're going to get 2 to 3. Okay, so the ratio of those two figures' perimeters is 2 to 3. Okay, find the ratio of their areas then. So areas, remember, is A squared, B squared. So I have to do 6 squared over 9 squared. 6 times 6 is 36. 9 times 9 is 81. And then let's see if we can reduce that at all. Okay, so one way to not have to reduce this is to use the 2/3 from part A as a little bit of an easier project, so you don't have to do all this reducing. But these are both divisible by 9, so 9 goes into 36 4 times, and 9 goes into 81 9 times, so we get 4/9. Notice that 4/9 is the same thing as 2 squared and 3 squared. So if you'd used the reduced perimeter ratio, A is 2, B is 3, then you could have just plugged in 2 squared and gotten your 4, and 3 squared and gotten your 9. If you don't do that and you use the real side lengths, you just have to remember to reduce your answer when you're done. Okay? All right, let's scroll the page up. And we are going to do these couple of examples. All right. Two similar polygons have corresponding sides in the ratio 5 to 7. Okay, so if this is my ratio 5 to 7, then this is my A and this is my B. Okay? Find the ratio of their perimeters. So we know that perimeter is A to B, so it's going to be 5 to 7. find the ratio of their areas. We know that's going to be a squared and b squared. So I'm going to do 5 squared and 7 squared, or 25 over 49. It's that simple. You're plugging it in to a over b or a squared over b squared. It's that simple. All right. Finding areas using similar figures. The area of the smaller regular pentagon is about 27.5 centimeters squared. What is the best approximation of the area of the larger regular pentagon? Okay. So here's what we have to do. If we look at them, 4 is to 10, then step number 1, I have to figure out what my a and b is. So 4 is to 10. I'm going to reduce that because they're both divisible by 2. So I'm going to get 2 to 5. That's my a to b, right? Side length, a to b. So if I know that that is the proportion of the side lengths, and I know that a is 2 and I know that b is 5, I'm trying to get the area. So I need to then move up and do a squared, b squared, and see what I have. So 2 squared, 5 squared. 2 times 2 is 4. 5 times 5 is 25. So that is the proportion for area. Okay? So this is the proportion for area, and I'm trying to figure out what the area of the smaller pentagon, or the larger pentagon, is. They've given me some information here. Area of the smaller regular pentagon. So here's what we need to do. We need to set up a proportion. And I just want to review for you again what a proportion is. Remember, that is 2 ratios set equal to each other. And how do you solve those? You cross multiply. A times d equals b times c. So we've talked about those a little bit this year on several different occasions. So this is my proportion for area. And would you say 4 is smaller or 25 is smaller? So obviously we would say 4 is smaller. So I'm going to set up my proportion. Smaller is to larger. Okay? So 4 is to 25. 4 being smaller, 25 being larger, is equal to. That's the proportion that kind of tells me how to change the numbers to find the answer. I know that the area of the smaller pentagon is 27.5, and since smaller is in the numerator, I'm going to put the 27.5 here, and then I'm going to search for the area of the larger, and that's what the question's asking me to do. What is your best approximation for the area of the larger regular pentagon? So step 1, find a over b. Step 2, find proportion for area. Right? So that's what we did step 2. This is what we did step 1. And step 3, set up proportion and cross multiply. That's step 3. So there are our 3 steps. So we're going to cross multiply. 4 times x. 4x equals 25 times 27.5 gives me 687.5, and then I'm going to divide by 4. Sorry, I'm writing over the other problem. I'll erase that for you in a second. So x equals 687.5 divided by 4 is 171.9. So there is our best approximation for the area of the larger regular pentagon. Remember, that's centimeters squared. Don't forget to label. So step 1, find a over b. Step 2, find the proportion for the area. Step 3, set up your proportion and cross multiply. All right, let's try it again. Next problem. Scroll the page up. We're going to try the steps again. One more problem. All right. So let me get this box out of the way for now. So the corresponding sides of 2 similar parallelograms are in the ratio 3 to 4. So step number 1, A to B is 3 to 4. Good so far? Step 2, the area of the larger pentagon. So this is larger. I need to find the area of the smaller. That's what I'm searching for. Okay, so let's find the area proportion, so I can then go ahead and set up my problem. So 3 squared over 4 squared. 3 times 3 is 9, 4 times 4 is 16. So this is my proportion that I'm going to use for the area. Okay? Step 3. Smaller is to larger. So 9 is to 16 as 96 was larger, so it has to go in the denominator, and I'm searching for the smaller one. So again, cross multiply. 16 times x is 16x. 9 times 96 is 864. X is being multiplied by 16. To undo multiplication, we use division. And so x is 54, and the label is inch squared. Nice. All right, please make sure you're asking questions if you are needing assistance.